Hello, everybody. Welcome to today's lecture. So today we're going to finish up our section on fractions. There's not really anything new to talk about. We just now kind of want to take what we learned in the last chapter. Well, actually, in the rest of the chapter, all of the sections, and we want to apply that to the linear equations, the solving equations that we had talked about before. So there's a couple of things I want to go back and do. First of all, one thing I forgot to mention in the multiplication chapter I want to address. Sorry, not the multiplication chapter, but the last one where we were adding fractions with different denominators. Okay, first of all, let's add one more example just as a review of what we were doing here. Okay. So let's say we have 3/5 and we want to subtract 1/6. Okay, so 3/5 minus 1/6. So the way we do this, we want to change the two fractions into equivalent fractions with the same denominator. So we need to look for a common multiple of 5 and 6. Now I mentioned last time, it doesn't necessarily have to be the least common multiple. It can be any common multiple. The least one is just typically the easiest to work with. But one trick you can do is that if you multiply the two numbers together, that'll always be a multiple of both numbers. Okay. So if you just take their product, you'll get a number that is definitely a multiple of both numbers. It might not be the least one, but it will be a multiple. In this case, it is the least one. But in general, that'll always work. So you can always use whatever that number is in order to find a common denominator. Okay. So we want to make both denominators 30 here. So let's move down here. So for the 3/5, we need to multiply 5 by 6 in order to make it 30, which means we also need to multiply the top by 6. So again, we're really multiplying by 1 here, right? Because 6 divided by 6 is 1. And when we multiply by 1, it doesn't change anything. So that's why we're allowed to do this. And then the 1/6, we multiply by 5 on the bottom, 5 on the top, because that'll make the denominator 30, but overall we've only multiplied by 1, so it's not changing anything. So on the left side, we have 18 over 30. On the right side, we have 5 over 30. And now we can just do the subtraction. We do the 18 minus the 5, and we get 13 over 30. Okay. Okay, so the thing I forgot to mention that I want to mention now is I said earlier in the chapter that the formula where we change a mixed number into an improper fraction relies on this idea of addition. Okay. So let's say we have 3 7/8, for example. Okay. So the way we did this before, I said we wanted to multiply the denominator by the whole number part and then add the numerator, and we just keep that over the same denominator. So in this case, we would get 3 times 8 is 24. Plus 7 is 31. So this would be 31 over 8. Okay. But why does this work? What are we really doing? Well, what we're really doing is finding a common denominator. We're just doing it with a shortcut. Okay, so remember 3 7/8. First of all, this is the same thing as 3 plus 7/8. That's just what a mixed number is. If we were doing this addition problem, well, remember, we can write 3 as 3 over 1. We can put any whole number over 1. So when we find the least common denominator here between 8 and 1, it's going to be 8. So we need to multiply the 3 by 8 over 8 so that it has a denominator of 1. Okay. And then when we do this, we're going to end up doing 24 plus 7 over 8. Okay. Because we get 24 from the first part, and then we want to add the 7 now that they have a common denominator. And this is exactly what we were doing right here, right? If you prefer, you could even rewrite this to see. We're doing 8 times 3 plus 7, which is exactly what we did in this formula. Okay, so that's why we end up doing this. That's why that formula works. Okay. All right, so that's all I wanted to mention about that part. This section is really short, so this is not going to be a long video today. But let's go ahead and take a look at it. We want to learn how to solve equations with fractions now. Okay, so what do we do when we have something like 2/3 plus x equals 7/3 or something like this, okay? Let's just solve this one first. We would work it exactly the same as we would before. We want to get rid of the 2/3. So it's a positive 2/3, so we should subtract 2/3 from both sides in order to get rid of it, okay? Because 2/3 minus 2/3 is 0, so on the left side we just have x. Then on the right side we have 7/3 minus 2/3, okay? Which they already have the same denominator, so we just have to subtract the top and we get 5/3. Okay. So we end up getting 5/3 there. Now, there's a few rules. Let me recap what we've done so far with equations. Okay, if we go all the way back to chapter 3, you might remember we introduced the division property of equality. So this says that we can divide both sides by any number we want. And back in chapter 2, 2.3, we had a similar property for addition. So this says we can add anything we want to both sides. And we have one for subtraction. This says that we can subtract any number we want from both sides. So the one that you might notice is missing is we have no property that says that we can multiply something on both sides. Okay, and we can. It does exist. We just haven't stated that yet. So let's write it down. Okay, the multiplication property of equality. Okay. So this says if A equals B, then A times C equals B times C. Okay. So we're just saying if you have some equation where you have something on one side, something on the other side, then you can multiply any number you want on both sides. Okay. So let's think about how this would work. What if we had 1/3 times x equals 4? Okay. So what do we do here? Well, we use what we know about fractions now, first of all. We know x times 1/3. Whatever x is, we can think of it as x over 1. So when we multiply these together, we do x times 1 on the top to get x, because no matter what x is, if we multiply it by 1, it's going to stay the same. And on the bottom, we do 3 times 1 to get 3. Okay, so we end up getting x over 3 is equal to 4. Now, we need to get rid of that 3 on the bottom. Okay, we want to just have x by itself. So And you don't even necessarily need to combine the fraction like I did here. You could have just done this in the first step and it would work just the same. I'll show that next. But if we want to undo the fact that we're doing x divided by 3, we should do the opposite. We should multiply by 3. Okay. If we multiply by 3, then these will cancel out and we'll just have x. Okay, because we'd have 3 divided by 3. But we have to do that on both sides according to our property of equality. Okay. So on the left side, we just have x, and on the right side, we have 12. Okay. So we end up with x equals 12. We could just as well do it in this first step. If you just recognize, okay, if I want to get rid of the 1/3, I should multiply by 3. Because remember when we defined a reciprocal, the reciprocal of 1/3 is 3, and any number times its reciprocal will give you 1, which is what we want. We want to have 1 times x. So multiplying 1/3 by its reciprocal, which is 3, will give you x, because the 3 times 1/3 is just 1. But of course, we always have to do it on both sides. So this gives us 1, and we just have x. And then on the right side, we have 12. Okay. So that's pretty much what we're dealing with in this chapter. Now, what if we have something like 4/7 x equals 5/12? Okay. There are two different ways we could do this. Okay. Let's think about what I think would be the most natural way to do it. Like essentially we can either do this in one step or in 2 steps. Okay. If we want to do it in one step, which I think is maybe more natural, recognize that we're doing 4/7 times x. Okay, it's a fraction, but regardless, what do we do when we want to get rid of something being multiplied by the x? We should divide both sides by that number. If we divide both sides by 4/7, okay, even though they're both fractions, 4/7 divided by 4/7 is still going to give us 1, because anything divided by itself is going to give us 1. So on the left side, we just have x. On the right side, it looks weird. We have a fraction divided by a fraction. Let's write it in the form that we're used to. Right? This is the same thing. 5/12 divided by 4/7. Sorry, sometimes I use that diagonal line for a fraction. I'm just out of habit. We haven't really used that though. So this up here and this is the same thing. We're just writing it in this one with the bar, and this one we're writing with the division sign. So now we think back to how we divide fractions. We do our same, change, flip. Right, so we leave the first number the same, change the division to multiplication, and then we flip the second number. So we have 5/12 times 7/4 in the end. Now we just do the multiplication. We get 35 over 48. Okay, so overall we get x equals 35 over 48. So we're just taking the rules we already learned and applying them, like the rules of how we solve equations combined with the rules of how we divide fractions. Okay. An alternative way here would be to take this one step at a time. Instead of dividing the whole fraction, you could say, okay, I need to get rid of the 4 on the top and the 7 on the bottom. So let's break it up into 2 steps. First, let's get rid of, say, the 7 on the bottom. It doesn't matter which one you do first. If we want to get rid of the 7 on the bottom, we should multiply both sides by 7, right? Because now the 7 on the top and the 7 on the bottom will cancel out over here. So we have 4x. And then over here, we have 5 times 7, which is 35 over 12. Okay, so now we're left with just 4x. Now, we just have to get rid of the 4. So we should divide both sides by the 4 because it's being multiplied. Okay. It's maybe better to write it on this side. Yeah, I'll write it like this first, but I'll change it in the next step. Okay, so we have the 4's cancel out. Here we have a fraction divided by a number, but if we write it like this, again, it's a little easier to deal with. We do the same thing as we did before with dividing fractions, because remember, this is 4 over 1. So this is the same thing as 35 over 12 times 1/4, because we do the same change flip. Now we get 35 on the top, 48 on the bottom. Okay, so we end up getting the same thing. So you could do it like this, breaking up into 2 steps where you divide on both sides first and then multiply on both sides, or you could do the opposite way. It doesn't matter. You could divide both sides by 4, then multiply both sides by 7. Or you can just divide both sides by the fraction. Okay. So let's do a couple more examples. One thing I did want to mention is 4.6 and 4.3 also we've kind of skipped. Those are dealing with adding and subtracting and multiplying, dividing mixed numbers. The best way to do that is to just take the mixed number, convert it to an improper fraction first, and then do the multiplication, division, addition, subtraction. Okay. So in general, we just don't want to work with mixed numbers directly. Mixed numbers are more for giving us an intuitive, a nice visualization of how much of something we have, right? It's easier to visualize what 3.5 of something is rather than 7 halves, right? Even though they're the same number. We can visualize having 3 of something and then half of another thing rather than just visualizing having 7 1/2 parts, right? So that's more for getting a sense of the quantities we're working with, but we want to keep it as an improper fraction to actually do the math, okay? Let's do some more examples here. Let's look at a more complicated one. Okay. So here there's a lot going on. We have a fraction being multiplied by the x, and we also are subtracting from the x. Okay. We haven't really dealt with any equations where we're doing 2 things at the same time. All of the equations we've had so far, we've been able to do at least in one step. This one, not so much though. So we need to get rid of the 2/5 that's on the x, and we need to get rid of the 1/6. So we should get rid of the 1/6 first. A good way of trying to decide which one to do first, it's kind of like looking at orders of operations backwards. So subtraction comes last, so we should try to get rid of that first in this case. The reason for that is because we're kind of, when we're moving things over to the other side, we're kind of trying to undo the problem. We're trying to reverse engineer it so that we can just figure out what x was. Okay. So we have to go backwards through the order of operations. We can technically get rid of the 2/5 first, but what happens is if we multiply, or if we divide both sides by 2/5, for example, we're going to end up having to divide the 1/6 by 2/5 as well. We can't just divide the x by 2/5 and expect it to be okay. Because we have to divide the entire side by 2/5. Before, we only had the x part on the side with the variable, but now we have 2 things. We have to multiply or divide everything by that number. Okay. So let's first get rid of the 1/6, because if we take the 1/6 and move it to the other side and combine the fractions, then we won't have to worry about that. So because it's being subtracted, we'll add it. So 7/6 plus 1/6, they have the same denominator, so we'll get 8/6. Okay. You can simplify if you want with the 8/6 down to 4/3, but I wouldn't worry about it until the end of the problem. Okay. So now, this is just like the last problem, and you can do it in either way you want. You can do it in the 2 steps or the 1 step. I'll do it in the 1 step, where we divide both sides by 2/5. Okay. So over here, the 2/5 cancel out, and we have x equals 8/6 divided by 2/5. And if we do the same change flip, we get 8/6 times 5/2. Okay. So we end up getting 40 over 12. And then you can reduce that. Top is 2 times 20, the bottom is 2 times 6. And then you can reduce it even more. This is typically how I reduce things. I just keep taking a 2 out of it if I can, instead of looking for a bigger number. So we can go 2 times 10 over 2 times 3. So we get 10/3. Alternatively, you could have taken out a 4 in the first step. Okay. But I usually just keep dividing by 2 until I can't anymore. And then whatever numbers are left, I try to figure out if they have a common factor. So we end up getting x equals 10/3 here. Okay. All right. So I think this covers every kind of problem you could encounter with fractions. Actually, I just thought of one more. Let's do one more. Okay. What if we had 2/3 x plus a half equals a fourth? Okay. Now everything has a different denominator. Here it wasn't an issue because when we went to add the fractions, they had the same denominator. So there's 2 ways we could do this. One is the direct way. Okay. So let me show the direct way first. The way that we would just think naturally to do it based on the last problem. Okay, if we did 2/3 x plus 1/2 equals 1/4. Well, if we just try to do it like the last problem, we would first subtract 1/2 from both sides. Okay. Let me just move over here. So we have 2/3 x, and then 1/2 minus 1/2 gives us 0. And we have 1/4 minus 1/2. Okay. So now we need to do the 1/4 minus 1/2. So we have to find a common denominator. So it just adds on this extra step of having to add 2 fractions. Well, in this case, subtract 2 fractions with different denominators. So LCM here is 4. So we can go ahead and multiply the top and bottom of 1/2 by 2 so that we can change that denominator to 4. Okay. So 1 times 2 is 2. 2 times 2 is 4. So we have 1/4 minus 2/4. So we're going to have 2/3 x equals negative 1/4. So we have a negative in here too. Okay, because we did 1 minus 2 on the bottom to get, or on the top to get negative 1. Now, excuse me. Now we have it back in the form of the first type of problem like this we did. So you can either divide by the fraction or multiply by 3 and then divide by 2. I'll divide by a fraction because I think it is the most natural way to do it based on what we did before. But it's all personal preference. Okay. So we have negative 1/4 divided by 2/3. Using the same change flip, we have negative 1/4 times 3/2. So overall, we're going to get x equals -3 divided by 8. Okay. So we end up getting -3/8. The second way to do this, which does make a lot of problems easier, I think this is the easier way to do it, is by clearing fractions. So the idea behind this method is that fractions in general make everything more complicated, right? It's definitely more complicated to work with fractions than it is to work with whole numbers. So why don't we just try to get rid of the fractions? Well, how do we do that? Well, if we multiply both sides by the least common multiple of all three of the denominators, okay, so we take the denominators and we find the least common multiple of all of them. Again, you don't have to find the least one necessarily even. You can just find a common multiple. Okay. The least common one in this case, because 2 is a multiple, or 4 is a multiple of 2, so you really only need to look for the least common multiple of 3 and 4, and then you'll be done, which is 12. Okay. Now, take both sides and multiply it by 12. Okay, so we do 12 times this whole side, and 12 times this side. Okay. Now, when we multiply the whole side by this number, we need to multiply each part by the number. So we need to take 12 and multiply it by the first number, and 12 multiplied by the second number. So 12 times 2/3 x plus 12 times 1/2 equals 12 times 1/4. So notice, if we kind of extend this out, because that's what we're doing 12 times 2 on the top. This is 24 over 3x plus 12 over 2 equals 12 over 4. But all of these divide evenly, right? 24 divided by 3 is 8. 12 divided by 2 is 6. 12 divided by 4 is 3. So this simplifies nicely into a problem where we don't have any fractions. So there's no adding two fractions with different denominators or anything like that. Okay. It just works. We work it back into a problem with just whole numbers. So now we can subtract 6 on both sides to get 8x equals -3. And then we can divide both sides by 8 to get x equals -3/8. Okay. So we get this, which was the same thing we got doing it directly. So you can do this either way. It's completely personal preference. The first way is maybe a little faster, but this way is, I think, easier. So it's up to you. But yeah, so I think that's definitely every type of problem we could encounter from these. So we're going to stop there for today. Make sure you do some practice problems of these because these are very important. I know fractions are one of the big sticking points for a lot of people early on in the math journey. So it's okay if it doesn't come naturally right away. Just do practice and it will come eventually. Okay. Let me know if you have any questions about it. There'll definitely be some homework problems on these, so you have lots to practice with. The book is a great resource for more practice problems. It has more practice problems than you could know what to do with, both like in the sections and then in the exercises and in the practice test. Okay. And there's also, there are solutions at the end as well for a lot of those. Okay. So you can check your work. So yeah, that's going to be it for today. So thank you guys for watching this one, and I'll see you for the next one where we start chapter 5, where we're going to start talking about decimals.